Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created several playlists to cover various categories of the problem such as trees, graphs, linked list, breadth first search, binary search, depth first search, dynamic programming, and so on. Don't forget to check them out. I have uploaded the code for this particular problem to GitHub repository. You can get the link from description below this video. Let's jump into today's problem. Online stack span. Write a class StockSpanner which collects daily price quotes for some stock and returns the span of the stock's price for the current day. The span of stock's price today is defined as the maximum number of consecutive days starting from today and going backwards, for which the price of the stock was less than or equal to the today's price. For example, if the price of the stock over the next 7 days were 180, so on, then the stock spans would be another output array basically. So now we are given with a problem like to calculate the stock span. So the span is defined as the number of consecutive days for which the price of the stock was less than or equal to the today's price, right? So basically, let's go with the same example as it was given, right? So this is the example, and then the spans. So this is we call array basically, right? Or we'll call it prices, right? And then span, right? So we will have something. So since 100 is the first price that we got, right? So then we would say, okay, all we are looking for the days going backwards and counting even the current day, right? So maximum number of consecutive days starting today, starting from today's and go backwards, right? So since we are considering today's also, we will say, okay, 1, right? So less than or equal to, right? Less than or equal to today's price. And then 80. So the second one, second day, the price, right? 80. So in that case, what we will see is, okay, is there any stock price less than 80? There is only one day that we have to look back, right? So is there anything less than 80? Not really. So we will say 1 again. And when we go 60, if there is any price less than 60, no, not really, right? So we go back, and on the fourth day, this is 70, the price is 70. Is there any price less than 70? Yes, 60 is less than 70. So 70, we say 1, 60, 2, right? So we will say there are 2 days which are less than price 70. And on the fifth day, 60. Is there a price less than 60? No. So it's already 70. So for this 60, even though there is 60 prior, right, but it's not the consecutive. That's what we are interested, right? Maximum number of consecutive days. So once we saw 70, we won't be able to go further. So that's why we would say for this 60, it's only 1 again, right? So going back to the next day, 75. Is there any price less than 75? Yes, 60 is less than 75. So 75, that we call 1, 62, 73, 64, 80 is less greater, right? So it'll be 4. And then 85. So is there any price less than 85? 1, 2, 3, 4, 5, 6. So 100, that is the only price, that is the start price, which is greater than that. So 6 is the days of the 85, right? So that is the answer essentially that we are looking for, right? So if you go back and compare, right, so it would be that one. So 3 ones to start with and 2, 1, 4, 6. So that is the stock span for a given list of price for 7 days. So basically what we are trying to do is, okay, we are storing all the prices as and when they are coming, right? Because in this particular example, we have the 7 days prices, but in the actual calls, each price will be given in a separate call, if you see, right? So let's go to the example 1 and try to understand, right? So StockSpanner, the initialization is empty actually. So on each next call, we are given with a price. On each next call, we are given with a price. So we don't have the knowledge of the future days stock price, right? So in that particular case, what we are going to do is we need to have a mechanism to store these numbers in a list or a stack or something like that, right? So in this particular case, I will use list for one approach, I'll use stack for another approach. So we are going to discuss two approaches for this particular problem, and one approach is a list and another approach is a stack. So we will say, okay, we need to have a mechanism to store all these prices in list, let's say, right? And we'll have to go through that list to find out how many consecutive days we have a price greater than or less than the current price, right? So that's what it is. So we are given with only one price for each next call, remember. So we need to have the older prices to make a decision on the new prices, right? New span. So the best way to do that is you need to have a storage for all these to start with, right? How many ever days that you want, you need to have the storage, right? So if you go through the example, that S.next is called and returns 1. So this is just the first thing that we have initialized as a stack spanner, and this is the first call for the next, right? So it's, since it's the first call, you just return 1, that's it. The second one, even though it is a second call, right, 80. So for that, if you want to come up with an answer like 1, right, you need to have the prior days. It could be 1, 2 or n days, prior n days worth of stock prices. Otherwise, you won't be able to make a decision for 80, right? So in that case, we need to have the storage for all the previous days also. So we will go with that approach to start with. So we will have a list which keeps track of all the previous days prices, and whenever we are given the next price call, right, we will go back the x number of days. So we don't know what is that x number of days that we will be going back to identify the span of the current stock price. So the x is 6 for 85, x is 4 for 75, x is 1 for 60, x is 2 for 70, right? We don't even know how many days that we are going to go back and identify the span of the current price, right? So in that case, we can't say how many times that we are going to look through the same number of elements again and again. So let's say we'll have to go back to x number of days to find out the current stocks span on an average, right? So that's one approach that we are going to look at, right? So the essential condition that we are going to look for is, as long as the next call we get a price and we put it in the list and traverse back to find out how many days we have the price is less than or equal to current price. So we just keep count of days to start with 1, because today's price we need to give at least 1, right? Anytime we have a lesser price, we have to just give 1 at least, right? So that's what we have been given for 100, 80, 60, right? So we'll have to give 1 at least. So we'll start with 1, and while we encounter a price less than or equal to the current price, we will increment the counter and finally return the that counter, right? So that's one approach. And the second approach, what we are going to do is, this is slightly a better approach, which will be using a stack instead of storing in a list, right? So we will put it into a stack. As and when we get a new next price, we put into a stack and identify how many of the previous prices are less than or equal to current price. And once we identify, we keep the cumulative days. So we keep the cumulative count of the span days, and then add an entry into the list stack with current price and the cumulative span days. So we will go through an example for this, right? So just like in the first case, we went through an example of, okay, the spans, right? So let's go through the same example and try to find out what we are trying to essentially do here, right? So in the second place, so here we will have a stack, okay, and these are the prices, right? We will have, okay, and my stack will have two pieces of information, right? The current price and the cumulative span of days. So when it is 100, the current price is 100 and cumulative is 1, right? And whenever we are 80, So since it is a stack, let me try to store in the stack format, right? So let me store like that, 100, 1. Okay. So the next is 80, right? So 80 is not less than, there is no price less than 80, right? So the price is less than current price. Is there any price? So the price which we saw is the last price, is, the top of the stack. So we will say top of the stack, right? So this is the top of the stack, and there is nothing less than 80. So we are going to put 80 and 1 again. So now the top of the stack is this one. Next is 60, right? Next is 60. So 60 also we don't have anything, so we just put it like that, and top of the stack is this, right? Now, so now after 60, right, next comes 70. So is there any price less than 60, right? Sorry, 70. So yes, so this is the price. So we knock this off. So we remove this, and the cumulative days. So our cumulative days always starts with cumulative days is equal to 1, right? Because that is what current price, that is 70. So is there any price less than 70? Yes, 60. The corresponding cumulative days is 1. So we update cumulative days to 2, and we knock this off. So our top of the stack will now point to this one. But since we knocked off, our top of the stack is 80. Is 80 less than 70? No. So we stop right there, and we insert 70, and what is the cumulative days? So this is what we are going to insert, right? Current price and cumulative span days. Cumulative is 2. So our top of the stack will be now this one. When you see next 60, so is there any price less than 60? No. 70, the top of the stack is greater than. So now we will say 61. So the top of the stack will be pointing to this, right? And next 75. Is there any price less than 75? So cumulative days will be 1 now. 75. So cumulative is 1. 75. Yes, 61. So cumulative days at 2. So our top of the stack will be 70. Is 70 less than 75? Yes. So 2 plus 2, it will be 4. So knock off this top of the stack, right? And now, so 80. Is 80 less than 75? No. So 75 and 4, right? Now 75, 4 will be our top of the stack, right? So 4 we are returning cumulative days anyway, so that is what we are supposed to return 4 anyway. And then next, now we are at 85. So now 85 cumulative days back to 1 again, and 85. Is 75 less than 85? Yes. So cumulative days is 1 plus 4, it will be 5, and knock this off, right? And this will be top of the stack. And 80. Is 80 less than 85? Yes. So 6, and knock this off, and top of the stack is this one, right? So now, so 100, is 100 less than 85? No. So now what we are going to see is 85 and 6. You return 6 also, right? So that's what it is going to be, right? So 85, 6 is now top of the stack is will be this one. So that's how we are going to proceed, right? So whenever we encounter, we push the element finally, right? That whatever the content that we are putting, the cumulative days, span days, we will be returning at each and every point in time. So that's the idea. Basically, for smaller data, you might not see a big difference between two approaches with the list or a stack. But if the number of elements or if the number of prices that we are getting as part of the next call is huge, right? In the first case, the list will be keeping track of each and every element in the list, right? So at the end of 7 days in the list, we had 7 entries, right? But at the end of 7 days in this list, in the stack, we just have only 2 entries. So this is a better approach in terms of the space and also the time. But if the things are always in the increasing order, right? sorry, decreasing order. Let's say if the stack prices are, let's say 100, 80, 60, 50, even 50, 40, 35, 25, right? So in this case, if this is an example, right? So both stack and list will have same amount of space, because the stock price is coming down every day, right? So that's the reason why you wouldn't see any big difference between the two approaches. But if you have the other than this case, right, in all other cases, you should see a better performance in terms of the time and space for the stack based approach. So we will go look at the code for both these approaches essentially, right? So okay, let me go back to the code now and show you the code. So since this is one single code, I will have declared the list of the prices, and the index is set to -1, and also the stack span is set to stack of span. The span is the one which is a placeholder class where I am using it to store these two pieces of information, that is current price and cumulative span days. So remember, I am showing two approaches in one single code. So there are not two different set of codes I have. So it's two approaches in same code. It's only like I comment out some part of the code and show you. Okay. So current price and cumulative span days is the span that I am calling. That is a placeholder class. Let me show you the placeholder class first. So it will have the value, whatever the price that we get every time, and the days. Days is a span, the number of days that price is holding. So this is a placeholder class for us. So with that, I am creating the stack variable, and the list variable will have only the integers. So we use either list or stack. So for the list based approach, we use the list. For the stack based approach, we use the stack. Okay. So that's why I'm initializing two of them in the StockSpanner class. So now let me comment out the stack based approach, and let's look at only the list based approach, that is without stack. Basically that's what I'm calling it, without stack. So what I'm doing essentially is I'm adding the prices with the current price, right, and incrementing the index, and using this get span private method to do the calculation for me, how much is the span for me, right? So let's go ahead and look at the get span, what it is essentially doing. So it keeps track of the counter, right? It keeps track of the counter and goes back to the list, and so count will have the number of days the current stock is holding up, right? So while current index is greater than or equal to 0, price of current index is less than or equal to price. We will keep on doing the counter increment and current index decrement. So essentially we are starting from the most recent stock price, and we are going back to the 0th index. So that means the first day of the stock. So let's say if it is 7th day. So let me go back to the example. If it is 7th day, that is 85. So if you want to know what is the how many number of days that stock prices was less than 85, right? You go back 75, 60, 70, 60, 85, and when it's 100, you stop, and you whatever the counter that you have accumulated, the number of days, you return that, right? So that's what I am essentially doing as part of this code. So while current index is greater than or equal to 0 and the price of the current index is less than the current price, right, you go into the loop and do the counter increment. That counter will have the number of span days. Finally return the counter. So that's what it is going to do, right? So let's look at the time complexity for this, and then go for the basically the stack based approach. So for this time complexity and space complexity, right? So time complexity, how much time we are needing, right? For each next call, we will be calling get span once, right? But as and when the number of next calls are incoming, right, the data that we have to store is increasing, right? So if you say if you have n days, right, if you have n days, the time required for first day is 1, right, second day is 2, third day is 3, fourth day is 4, fifth day is 5, and so on, n. So that will be So basically you will be going through that many calls, right? You don't know how much is the value of n, but you will have to spend through that many calls in worst case. So not best case, but in worst case, assuming that you are getting the stock prices, let's say in increasing order all the time, right? So let's say if your stock price is like 1, 2, 3, 4, 5, 6, 7, 8, let's say, right? In that case, so when you say 2, right, you'll have to go back 1 day. When you say 3, you'll have to go back 3 days. When you say 4, you go back to 5. So for 8, you'll have to go back those many days, right? So this is the worst case time complexity. Essentially, if you add all this up, right, it will come to order of n square. Okay, so this will be order of n square time. How much is the space required for this, right? So since you are saying n days, right, so order of n, right, for n days, where n is days, and for each day we get, and for each day we get one stock price, right? That's the reason why we will say order of n space. So for this time complexity will be order of n squared, right? So now go back to the stack based approach. So now let's comment this out, this section, and just enable this. So that's what is implementation with the stack. So we have that's the reason why I have initialized this list and stack in the constructor itself. So for this you could probably do this as well, right? Because you don't need the list right now. So we'll look at the stack based approach. Let's go ahead and look at it. So now I am assigning the span days is equal to 1 because we are considering even the current price also less than or equal to, right? If you go back and look at the description, right, less than or equal to today's price. That's the reason why we are looking for the span days is equal to 1. So if the stack is empty, that means today is the first day. Basically we are inserting the new price into the stack. In that case, what we will do is push the span. So this is where we are using the span placeholder class. So it will take two variables, right? One is the value, the price value, and the days, right? So if it is empty, the stack is empty, that means we are just starting, right? So PR and span days we initialize to 1. So it will be initialized as whatever the price and whatever the number of days, that is 1, right? So if you go back to example, right, so this is when we inserted 101, right? So 1 is the span and 100 is the price. So similarly we have the class to placeholder class for as called span, val is 100, days is 1. So that's what we are pushing onto the stack. So if it is not a first day, let's say, right, what we are essentially going to do is while stack count is greater than 0, we peak whatever the top of the stack, and if it is less than or equal to the price, whatever the price that is given today, then we will say, okay, pop the current thing, whatever it is there on the top of the stack, and add cumulative days to the span days, whatever the days that are there to the span days, and this will be done till we go to a price which is greater than the current price, right? Or the stack becomes empty, any of those two cases. So while we are out of this loop, right, then we will have to insert the current price, whatever we are passed, with the cumulative span days, whatever we have passed, right, whatever we have accumulated so far. And finally, after this call, we exited the else loop, right? We return the span days, whatever we have come across, right? So now let's go ahead and look at the time complexity and space complexity for this algorithm. So time complexity, right, and space. So here for the time complexity is highly depending on the data here, right? So but what we could say is the maximum number of times when we will be looking back, right? So if everything is in increasing order, right, if everything is in increasing order, we don't really have to how many times we will be going back and doing it, right? So 1, as and when 2 comes, it will be taken off and we only have 2. Whenever 3 comes, we will have only 3. So likewise, so if it is an increasing order, if we consider this one, right, this is a best case scenario for the stack. In that case, we will just need only one space of the stack if it is an increasing order, right? But if it is just like whatever the order that we got in the example 1, right? So even though it is 7 days worth of data, we ended up using only 2 spaces at the end, even though initially we used 3 spaces, but finally we ended up using how many spaces? Only 2 spaces. So there is not too much of gain that we will see for the space complexity. So first, let's say the worst case space complexity will be still order of n. So we haven't received any greater improvement in the space complexity for the worst case, because if the given data is all decreasing order, right, we will have to push we will have to have all of them in our stack. That's what we discussed already. So worst case space complexity will be still order of n. We haven't improved anything for that. So n is the number of days, as we have quoted previously, right? So let me put this there as well. So now, so time complexity, right? So how much time we are going to go back, right? So even though in the worst case we will have to go back to all the n places, right? So let's say if the stacks are always in the decreasing order, right? Let's say those decreasing order, right? So in that case, we just go back to only one location, one position. Here also we just go back to one position, right? So if the stocks are in the increasing order, we will just have to go one single position, right? But what if they are in decreasing order, right? If they are in decreasing order, the stack itself will have only one position to look at, right? So today the stock price is 1, tomorrow the stock price is 2. So but 1 is getting replaced by 2, right? So in that case, what we are going to essentially have is order of n space, right? So for the time, how many we are going to look back? Still 1. So the time complexity calculation is a little bit complicated here, but at a given time, what we would say is it will be anything between order of n, right? So it will be anything between order of 1 to order of n. That's what we would say, right? So the worst case complexity will be order of n, we would say. So we are able to increase the time complexity by n times, right? So that is how we are going to solve the problem in 2 different approaches. One is with the list, another one with the stack. So if you still have any further questions, please post them in the comment section below this video. I have posted the code to GitHub repository in 2 languages, C# and Java. You can find the links in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified with all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.